Mr. Moran making some lessons that I couldn't make last summer. So again, we're moving on to lesson 33. You have your do now here. If you missed the lesson, go ahead and pause me, read the do now. Give yourself to think about the question, read and try to answer it. And then you can unpause me and I'll go over it, okay? But we are going to get started. So spoiler. All right, I'm going to read it. So you're either using this as a review or you're maybe possibly watching it for the first time. I'll read it. Aiden has been saving money, Y, in a bank account that's been growing for $8 per month. After 24 months, he has $424 in the account. Aiden can represent his savings as a linear function because he has a constant rate, which is the slope of $8 per month. And we know a point that after 24 months, $424 in the account. We've seen one like this before. So we know our slope and we know a point. So we learned yesterday that we can actually find the y-intercept by using y equals mx plus b in the given information. So we know that the m for this problem is 8, and we know a point 24, 424, right? And that's our x and that's our y. Normally someone would come up and present, but obviously we can't. So what we talked about is that, well, we know y, and we know the m for this problem about Aiden, and we also know an x value. So we talked about just plugging that in, just like we've been learning how to substitute, into the equation. So y is 424, the slope is 8, and our x value is 24. And I made a big deal about it last lesson. You can figure it out, right? You can do it. So we plug in what we know. And now the only thing missing is b, and this is what we solved in chapter 1. We just have to do a couple steps. So I'm going to move this over here. Normally I would have someone come up and present, but I'm at home recording this video. 160, 192 plus b. And then I'm just going to solve the equation after multiplying m and x. And we get 232. So we know that our b value is 232. All right, and this one you didn't see. Now we can write the equation, which we discovered a couple lessons ago, in the form y equals mx plus b by using our slope of 8, and that our y-intercept, or our b, equals 232. All right, so think about it. I'm going to do it. It's just like here, except we're only going to put m and we're only going to put b. Now, we've got the equation that represents Aiden's money. Cool. And it also tells us a lot. Normally I'd ask questions like, what does this 232 mean, right? Y at 0 months, right, x is 0, there's $232. What does that mean, right? So we talk about the y-intercept means maybe what he had in the account. Maybe he got some gifts growing up. And then he planned on saving $8 a month. So boom, there we go. We've got it. All right. So if you're taking notes, if you're just watching, obviously don't take notes because you already took them. But we always do a heading. So this is 4.7 point slope form. And I always like to put down what the book says and write some stuff. So go ahead and read it to yourself. I'm going to read out loud. We've been learning about linear functions in the slope-intercept form, just like we did. And we learned, why do we call it the slope-intercept? Because the slope and intercept are numbers in the equation. And that's in the form y equals mx plus b. But y equals mx plus b is not the only form of a linear function. We have a new form called the point-slope form, which you haven't studied yet. But I bet you can figure this out. Since we call this the slope-intercept form, because we see the slope and the intercept, what do you think we're going to see in this new form, just based off its name? Well, duh, Mr. Moran, point and slope. Yup, you nailed it. Point and slope. Using one of my kids' crayons and I broke it. They're going to be mad. Okay. So, I would not want you to sketch it. We're actually not going to do it, but so if we wanted to know the equation that represents this line between the points -2, -4, and 5, 10, right? All the steps that it would take are here. To write a linear equation for the line, you need to find the slope first, then find the y-intercept, and then plug it into y equals mx plus b. Right? So, and just to remind us, I'm going to do this out. Fast forward if you already know what you're doing. Always good to review. So, remembering that these can be x1, y1. So I'm going to do it 10 minus -4. All right. So the slope of this line is 2, or 2 over 1, its steepness. Okay. Then we need to find the y-intercept. So we talked about we would take one of these 2 points. I'm going to take 5, 10. And the slope, and plug it into y equals mx plus b. So that's our 2, that's our 5, x is our 5, and 10 is our y. So 10 goes where y is, 2 goes where m is, x is 5, okay. Doesn't say, anyways, okay. I guess it was supposed to. So then you find your y-intercept, and then you can write the equation y equals 2x plus 0 by plugging in the slope and the y-intercept. That's a lot of work, but what's cool is, our new thing, is we don't have to write the equation in slope-intercept. We're going to learn about a new slope form, point-slope form right now. Okay. It's like people guessed. If you know the slope in any point on a line, you can write the equation for the line in this new form by using the slope formula. Let's take the information we know about Aiden's savings account, which we know that the slope of our do now is 8, and we knew the point 24, 424. Okay? And this point slope form comes from the slope formula. So I know we've practiced this a lot, so it's cool. Our new form comes from this. You just need to stretch your thinking just a little bit. Okay. So all we do is to use we're going to put m, which is 8, equals, well, we're supposed to have a y2 and a y1 and an x2 and an x1 to find slope, but we actually only have an x1, right? And we only have a y1. But that's okay. We'll put those in where they say. So we have a second y minus our first y, and our second x minus our first x. Boom. And we put in our slope. So that's point slope, Mr. Moran? Not technically, right? It's really close. We learned at the beginning of this chapter that x and y can't be divided by each other. So we have to write this in another form. But we also don't actually need these little 2's here, right? Because we're just left with a y and an x. And we put in the y1 and x1 here. So we're just going to erase those. We don't need them. They're just like numbers to say that's our second y and that's our second x. Okay. So this is so close to being in point slope. Okay. There's one more thing. You can't have x minus 24 in the denominator. Okay. And to do that, well, we have to undo x minus 24, which we were doing stuff like that in chapter 1. And we did that by multiplying both sides by this, the denominator. Because this divided by this cancels out. Or if we're dividing by x minus 24, we can undo it by multiplying both sides by x minus 24. These cancel. And now we have, I'm just going to move the 8 forward. 8 times x minus 24 equals y minus 424. Okay. So with just plugging what we know and doing one step, we're now in this form called point slope. Boom. And look, I see the point. Oh, I see the point. And I see the slope. Is 8. Sweet. Mr. Moran, we have to do this every time? No. You don't have to do it every time. But I wanted to show you where point slope comes from. And it just comes from our slope formula. And doing one math problem. Okay. Let's break it down to a little bit simpler, right? I don't want to get crazy. So here, just like any other formula that you've studied, like length times width, we just have a point slope formula. It's m times x minus x1 equals y minus y1. Okay. Y equals mx plus b is our slope-intercept form. A little bit easier to remember, but our point-slope form right here. And again, we call this the point-slope form because, well, what would you say, right? Well, m is our slope, and x1 and y1 is a point, right? That's it. That's the only thing you have to remember. It's pretty awesome. You don't have to find the y-intercept anymore. All right, show us how to do this, Mr. Moran. I know. Okay, we're going to write this equation in point-slope form. Okay, so take a moment, add this problem. We have a point on the line, 4, 2, and has a slope of 5. Okay, I'm going to mark it x, and let's call this x1 and y1. This is our only point, our first point and only point. And we know our slope is 5. Now, I can write the equation. I don't need to find the y-intercept. Like, Mr. Moran, why'd you show us? Well, you might like to. I don't know. So 5 times x minus x1 equals y minus y1. Ba-dam! Point slope. Nailed it. Yep, and that's full credit. That's the equation for that line. It's just in point slope. Okay, let's do another one together. Sometimes you have negative points and negative slopes. But again, the cool thing is there's nothing different. So go ahead and write down this problem. Point of negative 2, 5 and a slope of negative 7. And we're going to write the equation for this line without having to find the y-intercept. I'm plugging it again. There. Our slope is negative 7. Our x value, though, is negative 2. We don't like minus, well, I'll do it like that first. Equals y minus y1. Boom. We're basically done, except we're not fully simplified, right? We don't like minusing a negative number. And we had talked about that many times. Someone always reminds us, we're going to write this as x minus negative 2 is equivalent to x plus 2. Boom, we are done. That's it. You're going to say, Mr. Member, we have parentheses. Shouldn't we distribute it? Shouldn't we distribute? And the answer is no. We don't have to. I know we always want to, right, to simplify, but we're writing in a point slope. So we have our point, negative 2, 5, and we have our slope, negative 7. All right, here's a chance. Go ahead, take a moment. Maybe you got it. I don't know. If you can do it a couple times, I feel like you're rocking and rolling. You just got to put them in the right place. So go ahead, take a moment, pause me, do C and D. I'm going to keep going so we keep the video a little shorter, right? So 2 times x minus x1 is y minus y1. Boom. Wow. All we need is a point and a slope, and we're done. Yep. Point slope. And we don't like the double sign, so I'm just going to rework it. Big germ. You know, if you get here, that's like 90% correct, right? I'd love you to bring it down a little bit more here every time, but you know, if you got to this point, that's great. That's like 90%. Okay. And students often say, Mr. Why is it a plus? Well, because it's minus a negative, right? We're minusing a negative, and we write that as an addition problem. All right. Now, part 2, right? Well, I know some of you wanted to do distributive property. Everyone always raises their hands. And actually, we can do that because we can take an equation that's in point slope, and we can really easy, if we wanted to know the y-intercept or write it in the form, the slope-intercept form, all we have to do is going to solve it for y. So if I have the point 3, 5 and the slope of 2, I can write the equation in point slope. But say I wanted the slope-intercept. It might be easier to graph that way or something. Well, sure. Then what I'm going to do, it's 2 steps. First, you're going to distribute. Right, like you wanted to. And then I'm just going to solve for y by adding 5 to both sides. You got to watch your subtraction, but if you have negative 6 plus 5, we're at negative 6, and you go up 5, you're going to end up at negative 1, or however you want to do it. Boom, we are almost now in point slope. I'm just going to swing it around. I'm at slope intercept. There we go. Y equals mx plus b. That's pretty easy, Mr. Moran. Well, I hope. You know, we've been practicing distributing. We've been solving equations. We're just going to use what we did in Chapter 1, Chapter 2, to turn from point slope into slope intercept. All right. We'll do another one here. So again, you have a point and the slope. Super easy to turn in a point slope. We're going to distribute first. Right? And then we're going to subtract 3 this time. We're going to undo, get y by itself by subtracting by 3. And then we are now in basically slope intercept. Just rewrite it the other way, though it's the same. Sorry, everybody. Okay, sorry about that. My computer went to sleep. That's weird. Make sure I touch this. Okay, there you go. So, kind of learning 2 things today: point slope and turning it into slope intercept. So, take a moment. I already wrote down the equations, linear equations and point slope. Turn them into slope intercept. Be a great chance to pause here. Try it on your own. I'm going to keep going. Sorry, there we go. 5x minus 18 equals y, and negative 5x minus 9 equals y. Okay, let's see. Yeah, so I have some practice for you here. Okay, this would have been done in class. If you look, the top has an example of writing it in point slope, and here's turning it into slope intercept. Oh no, write the point slope. Oh, it's just point slope. Again, another example of using point slope, but simplifying a little further. All right, so go ahead and work on it. I'm going to do it right here and give people the answers. And again, we're just going into point slope. So. Okay, I have all the equations in the form of point slope. Not having to find the y-intercept, not needing it. We wrote the linear function. Okay. What I would do once people got ready, I would say, then rewrite in slope intercept form. So for all of these, go back and do the next step, which is to turn them into slope intercept. Reminding yourself to distribute, and then solving for y. All right. So, hopefully you did the classwork by yourself, and you weren't just copying what I had, because it's good to practice. But here are the answers for any ones that you wanted to see again, like say you were not sure or you were confused in class. Here's all the work and the answers for the most part to solve all of these. All right, cool. And that's the end of lesson 33. I'm sure the homework is posted on Google Classroom. If not, I'll tell you in class. Or you can probably check on Google Classroom.